Good morning, what's up guys, and girlies and guys, what's going on? I'm just getting up. I was asked to do just a rundown. I'm going to do a thing on our solar system, and then the next couple of days, well, probably the next all week, I'm going to be breaking down all the planets, and then we're going to do all the moons. It's going to be super, super cool. So join me on this one. It's going to be awesome. It's going to be like a week of all of our neighboring everythings. So go get coffee and wake up, and I will be right back. This will be fun. This will be a lot of fun. I can't wait. Drop it. Drop it, Lincoln. Drop it. How am I supposed to get that if you won't drop it? Huh? Huh? What's up, everybody? So this is going to be a cool. I'm going to break down our whole entire amazing solar system. Kind of. I mean, you know, in my normal talking, it's actually, man, God, I don't know what the hell, I walked in here, I was sweating balls, I mean, I had a hoodie on and shit, I don't know why, but, dude, and it's been awesome, the weather's been super cool around here, like, really, really nice, I love the hell out of fall, it's a great time of weather. Oh, before I start on anything, George, my bestest friend in Australia. I was talking to my friend in Australia, and man, it just went off. I only have 2 hours. Podbean only lets me do my my podcasting for only 2 hours. And our 2 hours was up, and so it just cut off. God, excuse me, Lincoln. What did I tell you about burping and having gas whenever we do this? You could have done that any other time, but right now, and you get on there and you just start belching yourself. What is wrong with you, boy? Oh my God, Lincoln, what's wrong? You okay? You okay? With your ball? Oh, you don't know where your ball went? Oh, shit. Well, ladies and gentlemen, we have a problem. Houston, we don't. Hey, here's your ball. We found ball. We're good. I swear to God, ever since I got this thing for Lincoln, he has not dropped this thing, and we have not lost it, not once, since we got this ball and little thrower thing. It has been the best thing I've ever got for my aminals. Come on, let's go. Back here, back up, back it up. I love the L out of my dogs. I don't know, man. Bentley doesn't get to go into outer space as much as me and Lincoln, but occasionally. And sometimes. Oh, shoot. There it is. And Bentley's a little bit meaner, so I don't know, we have to bring him out with me. Yeah, I don't know. As nice as I am to my dogs, I swear to God, I don't understand why they're the meanest animals anybody's ever seen. Oh, but not to me. Ain't nobody me. Well, no, Bentley. Me and Bentley have gone at it, man. I mean, full blown on, like, taking the gloves off and gone at it. Yeah, I mean, like, yeah, it's been no holds barred. Do that. Please don't do that. Just drop the ball. Oh, no, Lincoln. Oh, fuck me. Oh, no. Lincoln, you fucked up my mic. Uh-oh. Oh, well. So, I hope everybody can hear me. Let me check this. Oh, I can still hear. Okay. We are not screwed, Lincoln. Stay there for a minute. Yeah, so, how's everybody been doing? I have not really been able to do this lately. Not as much as I've wanted to. It's just been one of those things, where just, but, however, I've been saying that I'm going to be doing this stuff differently, and blah, 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 and I'm going to. I can't wait. So, okay. I opened up this fan page thing, right? And I'm still learning how all this stuff works. I'm not real well into. I'm learning. I'm going as I'm going. And as I go, it's whatever. There was a point to that. Anyway, so it's not been as much as I've been wanting to, but I'm saving you guys from having to hear my voice. I mean, dude, you'll most people probably don't listen to it anyway, as is. I mean, which is, it's alright. I don't blame you. Alright, so, as I was getting on and saying this more and more about, so, what was the? Oh, yeah. So I'm gonna be doing like I don't know. I've been saying this. I'm gonna just do things differently. So okay, I'm gonna be doing my. Okay, so I guess. So I guess what I'm gonna be doing. My friend, I think Kevin is gonna be. I'm gonna. He's gonna let him in on this whole thing, and he's gonna start helping me full time. I just, man, it's a lot to do, you know. And see, Tuesdays and Thursdays, I believe, I'm gonna be doing like full on. I'll probably show, and then if you're in my fan base thing, then you can get on. You can hear me like every day. But then if you're not, I guess it's just Tuesdays and Thursdays. I don't know. I mean, I don't think it'll. Yeah, probably nobody will even notice. So I don't even know if anyone will notice. So I got a thing asking if I would do stuff on the solar system. So and also things on. I need to be. I start to get like lost in doing like this conspiracy thing, which is cool, but it's not like astronomy stuff. So I'm gonna be doing like solar system stuff. Then I'm gonna be breaking down planets. Then I'm gonna be breaking down the moon. Wait till you get to Jupiter. Jupiter is a solar system in itself. Super, really, really cool planetary system, as you would call it. It's Jupiter in itself is amazing. It's actually supposed to. It's so big. It started itself as to be a sun, and well, it didn't make it. It didn't make it at all. It failed, but man, it's. We'll get to it. So like I said, I'm gonna be doing like a thing on solar solar planets. You know, it's. I didn't choose to be born down. It just happened. It did. So if I'm not looking at my phone directly, I apologize. But I will. I'll glance at it as I go, and stuff like that. But yeah, wait till we get to Jupiter. Super, super cool. And what's crazy is it's not that the solar system changes. It has nothing to do with that. It's just we keep learning like more about it. I think in like 2006, I mean, we haven't made it out to the outer planets really that much. It's been sort of a, actually, I think, well, Cassini, but come on, Lincoln, come here. But we really haven't made it out that much. Voyager 1 and 2, that was in the 70s, and like, well, by the time they got out there, it was in the 80s. But, yeah, we really haven't. So, but we keep learning. I mean, now we have like, James Webb and other things that are like, shooting super far, checking out super, cool stuff. We're finding out new stuff, and it's super cool all the time. So, running down things every, 10 or whatever years, 50. I don't know. Things are way different when I was a kid. I'm just going to say that. No, and like, I don't know. So I'm going to do a thing I think. Just breaking down like our solar system because it's really super cool. Oh, there's some really cool things too. I'll talk about it another time. Yeah, so I don't know. Our solar system is a complex, very, very cool. It's really, really cool how, I don't know if you've ever really heard it broke down. Our solar system is made up of the sun and all the amazing objects that travel around it. The universe is filled with billions of stars located inside galaxies. These cosmic arrangements are made up of at least one star and all the objects that travel around it, including planets, dwarf planets, moons, asteroids, comets, and meteoroids. And way more. The star system, I probably could have added so much more, but I didn't. The star systems we're most familiar with, of course, is our own. And Lincoln, come here. And I even forget about, like, no, I don't forget about it. There's just so much to it. God, when I was doing these, this is why I want somebody to help me. When I was jotting down the stuff for this, I was like, God, I need someone to help me do this because there's so much stuff I don't want to leave out. You know what I'm saying? And I'm like so afraid that I am. But if I do, you guys gotta hit me up and let me know, and I will fill those gaps accordingly and funnily. Even though that's not a word, but I'll make it one. Okay. So, not home sweet home, but in our little tiny little pocket corner of our awesome galaxy. If you want to look at a giant picture of space, zoom in on the Milky Way galaxy and zoom in again on one of its outer spiral arms, you'll find our solar system. Astronomers believe it was formed about 4.5 billion years ago when a massive interstellar cloud of gas and dust collapsed on itself, giving rise to the star that anchors our solar system, that big ball of warmth known as our sun. So, when our sun exploded, man, it left a real, leaves, it blows up and it leaves all this, what, Lincoln? Come on, don't do that. Although I've learned when you speed up his bark, it's pretty goddamn funny. And as that cloud of dust, it's real cool. Honestly, I thought about doing video things. Because it's pretty cool how you can break that stuff down. And I think that you can get programs for your computer that help you. I don't know. I'm looking into it. So, yes, along with the sun, our cosmic neighborhood includes the 8 major planets. The closest to is the sun. The closest to the sun, of course, is Mercury, followed by Venus, Earth, and Mars. These are known as terrestrial planets because they're solid rocky. Beyond the orbit of Mars, you'll find the main asteroid belt, a region of space rocks left over from the foundation of the planets. Next comes the much bigger gas giants like Jupiter and Saturn, which is known for its largest ring systems made from ice rock in both. They did not, they were scientists. They didn't know that Jupiter would have rings. And I was watching this thing, and this guy claimed to be a remote viewer, was saying that he was like, the government, it was a government, he was working for the government, and they wanted to see if he was accurate on it. And so they wanted him to look at a planet that was way out, and he didn't. He mentioned something about it being, I think Jupiter, and they were like, no, it doesn't have rings. There's no way. Well, when Voyager 1 went by, it got cut. They took a picture, and they were very small, but it's there, hint of a ring system around Jupiter. Pretty cool. But anyway, I keep talking about Jupiter, and it's such a cool planet, though. But yeah, so beyond the orbits of Mars, Jupiter and Saturn, which is known for its large ring system made of ice rock and both. Farther out of the ice giants is Uranus and Neptune. You want to laugh, though. Uranus is way out there. Beyond that, a host of smaller icy worlds congregate in an enormous stretch of space called the Kuiper Belt. Perhaps the most famous resident there is Pluto, which I don't know. It sucks that they took Pluto out because I grew up as it was 9 planets. Pluto, and actually it's funny because Pluto is actually the most, if there's life on a planet, it's probably going to be Pluto. I mean, it's frozen and it's way out there, so it's not like but if it were an inner, if it were further in, obviously like then it more than likely would probably, I don't know. You know what? It's not, so I can't say that or not. There are more than 150 moons that orbit the worlds in our solar system, known as natural satellites. They orbit planets, dwarf planets, asteroids, and other debris. Among the planets, moons are more common in the outer reaches of the solar system. Mercury and Venus are moon-free. Mars has 2 small moons, and Earth has 1. Meanwhile, Jupiter and Saturn have dozens, and Uranus and Neptune each have more than 10, but probably find more, time goes on. In 2006, I think there were only like, I don't know, 40 something moons. And now I got it. I'll get into it. But they find more and more. And man, I really try to be accurate on all the stuff I put on here. I can't stand people, or I'm not going to say people. I can't stand when I see videos of or hear about people talking about, and it's total bullshit. And they're just spatting out crap, just false information that's completely just. I saw this thing about this video. It was almost cool, almost awesome information, but Voyager 1 is not coming back to. Never mind. I'm not gonna get into it. It's just like I gave him an earful. It was pretty bad. Yeah. It was real bad. So even though like Pluto is relatively small, it was moved into a dwarf planet, so they don't even consider it in the planetary world of us. It's a dwarf planet. And how you it gets into the Kuiper. I mean how you distinguish a planet from a dwarf planet is really it gets into Kepler's third law. A planet, there's 3 things that make a planet a planet. It it's round enough, gravity is strong enough to make it a sphere, so it's spherical. It orbits around the sun, and it's got a clear path. It's totally doesn't have any junk debris, although that's not so much true, as Jupiter's got a massive amount of asteroids in front of it, and a big thing of asteroids behind it too that go in its same orbit. So I guess that can't be so true, but for the most part, it has to clear out all the debris in its orbit. And the third one is no shit. No, I didn't forget the third one. Oh my god, I did oh man, that's shitty on me. I'll get that though. I will get that. But the Pluto and its moon, Charon, are a binary system. It's actually like it's actually not so much a moon. Maybe it is because it's a dwarf planet, but it's more like 2 planets that are. It's more like a binary system of planets. So So I always consider it being 9, but that's just me. Too small to be called planets. Asteroids are rocky chunks that are also. I hate that word, chunks. I cannot stand it. I'm sorry that I put that in there. You know what I mean. There's just some words that you hate. Well, that's one of the ones I hate. So I don't even want to say it again. I don't know why I put that down there. I won't do it again. I promise. Tens of thousands of asteroids are gathered in the belt that lies between the orbits of Mars and Jupiter. Comets, on the other hand, live inside the Kuiper belt and even farther out in our solar system in a distant region called the Oort cloud. The Oort cloud, I had no clue that it is as thick with rocks, asteroids, and comets as it is. There's actually, man, way out there are so many. There's dwarf planets. I guess we don't know about, but but there's huge. I don't know if huge dwarf planets really is how you would say that correctly, but it's something. how would you say that? Huge dwarf planets. I don't know. So the solar system is developed by a huge bubble called the heliosphere. Made of charged particles generated by the sun, the heliosphere shields planets and other objects from high-speed interstellar particles known as cosmic rays. Within the heliosphere, some of the planets are wrapped in their own bubbles, called magnetospheres, that protect them from the most harmful forms of solar radiation. Earth has a very strong magnetosphere, while Mars and Venus have none at all. They completely lost their magnetic the heliosphere. It's basically what shields them from the solar radiation that comes flying in from the sun. Most of the major planets also have atmospheres. Earth is composed mainly of nitrogen and oxygen, key for sustaining life. The atmospheres on terrestrial Venus and Mars are mostly carbon dioxide, while the thick atmosphere of Jupiter, Saturn, Uranus, and Neptune are made primarily of hydrogen and helium. Mercury doesn't have an atmosphere at all. Instead, scientists refer to it as extremely thin covering of oxygen, hydrogen, sodium, helium, and potassium as an exosphere. Moons can have atmospheres too, but Saturn's largest moon, Titan, is the only one to have a thick enough atmosphere, which is made mostly of nitrogen. It's actually pretty. God, I should. You know what? I was honestly, I wasn't even gonna do the solar system, but I was asked about it. I was actually gonna do Jupiter's moons because it's its own solar system, really, in itself, and God, there's so much cool stuff that they're finding out about Jupiter and all of its moons. It's really, really cool. Yeah, I was amazed too when I was doing a thing on blah 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 on our on God, I'm so stupid this morning. It's early. What can I say? But there are many planetary systems in our universe. With planets orbiting a host stars, our planetary system is called the solar system because we use the word solar to describe things related to our star, after the Latin word for sun. Wouldn't you know? Our solar system is made up of a star, 8 planets, and countless small bodies, such as dwarf planets. Our solar system orbits the center of the Milky Way galaxy at about 515,000 miles per hour. That is 828,000 kilometers per hour. God, and man, I used to think, I was taught growing up that our solar system was just sitting there. You know what I mean? It was not moving. I don't know, but I guess I was stupid. But we're in one of the galaxy's 4 spiral arms, lying around. I think it takes like 150 million years to go around. I think for one. What would you say? One spin around the Milky Way galaxy? Really, that's what I should do. Is the thing I should do. Man, our galaxy is so freaking huge. I'm gonna do a real cool video thing on the Milky Way galaxy that's super, super cool. I got a thing I'm gonna play on it too that's really rad. Like the Milky Way galaxy. It's our galaxy. We are always so busy talking about other galaxies and man, our Milky Way galaxy is so big. It's the nuts. But I'm gonna be there's a cool thing I'm gonna be playing on that here in just a few today. But it takes our solar system about 230 million years to complete one orbit around the galactic center. Yeah. See? I told you it was 150 million. 230 million years. So, I don't know, a couple of years after I was born, we made it around halfway. So, there are three general kinds of galaxies. There's elliptical, spiral, and irregular. The Milky Way is a spiral galaxy. Our solar system is a region of space. It has no atmosphere, but it contains many worlds, including Earth, with many kinds of atmospheres. The planet of our solar system, and even many asteroids, holds hundreds of moons in their orbits, and the four giant planets and at least one asteroid have rings. None are spectacular as Saturn's gorgeous, gigantic rings. Saturn's another really cool one. More than 300 robotic spacecrafts from many nations have explored destinations beyond Earth's orbit. There was a thing about Voyager 1 and 2. Come here, Lincoln. Come here. Don't go far out there. And our solar system is the only one known to support life, as you know. So far, we only know of life on Earth, but we're looking for some elsewhere. I think that the moons of Jupiter and Saturn are going to be where life is sitting. Honestly, I don't think scientists say that. That's better than they say. You know what I'm saying? Scientists think that Io, I think, or wait, or is it wait, which one? I think it was yeah. Well, actually, maybe it's Europa. If the moon probably has rings, but they call the Milky Way. Hey, what's up, man? I'm sorry, I didn't look at my phone until just now. The reason they call the Milky Way the galaxy's Milky Way is, yes, that's exactly why. When you look up and you can see it almost looks like milk. There's so many stars, and so it doesn't even look like stars. You see that haze that looks like milk through it, and that's why they call it the Milky Way, because there's just so many stars in one. When you look up there and you see that, you're basically looking at, honestly, you're probably just seeing like the arm of what the galaxy is. But as you look, there's so much light coming from all those stars, it just looks like a huge cloud, which I guess I'm assuming before we had all these really, really awesome telescopes and stuff, which I couldn't imagine what it would have been like in 1610, Galileo, when he found the moons of Jupiter, the four moons, well, I'm sorry, it's not the four moons, it's actually, I think there's like, 80 something moons of Jupiter, but the four main moons, are, there's a really cool, hang on, anyway, Galileo in 1610 found, he was looking at Jupiter, and he saw these other stars that were going around, that were around it. He thought his telescope was messed up, and then I think the next day he looked up and there were four, and he was like, holy shit. And that's how he discovered that we were not at the center of the universe, actually. And that's when he got in deep shit and got thrown into jail for saying that we were not at the center of the universe, that we revolved around the sun, and the sun was the center, and everything revolved around that. And that is how he found out that we were not the center of the galaxy. Really, really cool. And that was in 1610. Can you imagine those people? If you want to say, they are the rock stars of humanity. I mean, they figured all this stuff out before huge telescopes. I mean, really, honestly, I think, well, I mean, obviously, you had to look at the You know, he had to look at the through a telescope, look at the planets, and they could tell from the four, from closer in comparison to the back ones, which ones are moving, which ones were planets. Um, but man, they figured a lot of that out just by not even lifting a pen. Well, an ink and a, but all the same. Sorry, I'm completely like, it's so early. I feel like I'm stumbling over my words. I apologize deeply. I should pre-record these, and I'm going to start Tuesdays and Thursdays. I'm going to do like really awesome pre-recorded uh, um, shows, podcast shows. But then if you're in my fan base club, then Monday through Friday, uh, you can join my live thing, I guess. I think that's how I'm still kind of, getting lined out. My friend Kevin's going to come in and help me, but Clayton, I appreciate you joining. And Ronald, what's up? Thank you. If you guys haven't, and hit like. I do these every day in the morning. If you want to join my fan base, I do it every day. I do one, and then I'm just starting this Tuesdays and Thursdays. I'm gonna do like the 2-hour ones. Podbean only lets me do 2 hours because I can't get to level 2. Me and Lincoln, my doggy, they will not let us past level 2. Lincoln is, well, he's out and is flying around in his UFO today. Man, thank you, Clayton. I appreciate it. Thank you very much. Thank you for joining us. It's really awesome to meet you. I love meeting new people that come on here a lot. Super, super, super cool. Oh no. Okay, but I'm going to take a short break. I'll be right back. Don't go anywhere. Don't go anywhere. I'm gonna play this. It's normal.
Well, who's on there?
Nobody.
I can't get on.
Why?
Because I can't have apps.
Oh.
That's why Jake and I are going to Verizon.
Oh, are you?
Yeah, we decided to pay it together. He's like, let's trade our phones in. I need a new one, but I need to make payments on it. I was like, okay, I'll do it. I was like, you gotta pay for it. I was like, Mama Marie. It's like, not fucking yet. I haven't seen that enlistment check yet, baby. And they don't give it to you before you go. I was like, you gotta go.
All right, I will be right back.
I don't know how much he's getting paid, but
Lincoln don't.
He's already buying plane tickets and shit.
Really?
Yeah.
Okay,
Yeah.
I'm sorry. I'm trying to get this to.
Our plane tickets to San
Sorry,
Diego.
I'll be right back.
Who's there? You said nobody.
A bunch of people that listen?
Well, who listens? That's what I want to know.
I don't know. What do you mean?
Well, don't you have people that add on to it? Can't you see who's listening?
Well, yeah.
Who's listening?
I don't know. List of people.
What are you talking about?
The solar system?
I thought you talked about aliens.
No, I don't do alien stuff. I don't do conspiracy stuff. I don't.
Dude, that was your thing forever, babe. Oh, sorry.
Yeah. No, I don't do it. I only I get into it, but that's why I'm not speaking. I always try to speak with like.
Okay, well that's why I never. That's why I never got.
Aliens aren't
Really?
no.
I guess it reminds me of God. After mom. You know what I mean?
Within this region, stars are typically only a few light weeks away from each other, unlike back at home in our galactic neighborhood, where they are separated by many light years. Around here, stars are so packed together that if you found yourself standing on one of the orbiting planets, you would witness the blazing light display. Every single night. Surrounding the very center of the galaxy is a swarm of bright, giant stars orbiting an invisible object, a sleeping giant. These stars are moving so fast that many of them complete one rotation of this mysterious object in just a couple of decades, a journey that takes the sun more than 200 million years. After 26,000 light years, our journey is nearing its end. That dazzling bright light dead ahead is Sagittarius A star, our final destination and the very center of the Milky Way galaxy. The home of a cosmic monster, a supermassive black hole. Perhaps the most intriguing object in the galaxy, Sagittarius A star, is the ultimate consequence of gravity. It has a mass 4.3 million times that of the Sun, all concentrated within an area smaller than the orbit of Mercury. What we are currently observing, however, is not the supermassive black hole itself, but the swirling, superhot material surrounding it. That rotating ring of debris is called the accretion disk and is a thin flow of gas and dust that has not quite fallen into the supermassive black hole. Instead, it forms a flattened band of spinning matter around the event horizon, the point of no return. Those powerful jets blasting out into space are also partly created by the accretion disk as it falls towards the supermassive black hole at the center. The plunging material spins faster and faster, becoming hotter and hotter, producing magnetic fields that, along with a spinning black hole, winds up into a twisted cone that reaches thousands of light years out into space, extracting torrents of lethal radiation. Now we have made it to the end of our journey, to the core of the Milky Way galaxy and into its chaotic heart. But just like the material that crosses the event horizon of a black hole, this is a one-way trip. There's no turning back now. We've come too far. Did you enjoy this epic journey from Earth to the center of the Milky Way galaxy?
Yay, that was fun. Alright, I am sorry. Man, I really can't wait to get, this stuff worked out a little better. But I'm working on it. Anyway, that's a really cool breakdown of our solar system and the Milky Way galaxy. God, it's crazy when you think about how big. Man, there was a size to scale. It's so amazing. I've got these, actually, let me get this together real fast. I didn't mean to really jump on here like that, so I'm sorry. I'll be right back. Don't go anywhere. Where did I put those papers? Alright, I'll be right back. All right. Sorry. I apologize. I always have my stuff together so perfectly well that everybody wants to. Just kidding. I'm joking. Please know I'm joking. I'm always joking. I'm very sarcastically joking because I know that I'm a weed. And I know my voice gets absolutely annoying, though. That's why I play these fun little things, so that not everybody doesn't have to get highly annoyed by my annoyingly voice. Anyway. So yeah, man. It's really cool if you break down, without getting too much into physics, which I love the hell out of, but man, there's a fine line, where you get into that way. It's like whoa, and that fine line is very fine. And I find myself drifting into the annoying for half of physics where I'm just like, where even it was like, man, that's just too much. And I'm like, I know, I apologize. I deeply apologize. Actually, I know people can understand way more than me because I'm just not that smart. um, so yeah, so with that being, and I know that you guys didn't know what planets were in our solar system, so I had to make that, I had to, go through that to let you guys know. I know that everybody only knew of Venus and Mars, with all the, stuff going on. So I thought I would tell you everybody about the new planets that nobody knew about, Mercury, and so on. So now that you guys know these planets in our solar system that you've never heard of, I'm clearly kidding. Now I can go into how planets are born. They're born, obviously, from clouds of gas and dust that orbit new stars. Billions of years ago, circumstances were just right for Earth and other planets in our solar system to form. The solar system that we live in consists of medium-sized stars, a medium-sized star with 8 planets orbiting it, which I still think Pluto. Man, when I was growing up, Pluto was I cried in 2006 when they took Pluto out of the equation. I was like, no. There's a real cool shirt. I want to get yeah, it was basically from Pluto. And I wish that. Yeah. Anyway, the more and more that they learn about Pluto, though, I think that it was the scientists are. I think it was Cassini that went to Pluto. There's actually a binary system with Pluto. There's another planet. And it's too big, I think, to be a moon. Come here, Lincoln. What's up, man? How you doing? Oh, everything going all right? Good. Okay, Lincoln. Here you go. Go get your ball. Go get your ball. Sorry, everybody. I'm at work. I get here early, and then I do this and wake up. I'm sorry. I couldn't put you guys through that. I apologize. I'm working on doing all this differently. I really, really am. But if you guys have any recommendations, I always love hearing. And you won't hurt my feelings, I promise, because this really is for you guys, and you guys have to hear it, and so I always am open to idea or what I should be doing. Probably take this out. I think people should turn that crap down. So sorry, I apologize. Yeah. So the planets are of 2 different types. The 4 inner planets, those closest to the Sun, are Mercury, Venus, Earth, and Mars. They are smaller, composed mainly of metals and rocks. That being said, obviously closer to the Sun. Although, you know what? Okay, that's not true either. And I start to say something. I'm like, no, wait. I contradict myself constantly. Because scientists think that Jupiter was actually, and the more exoplanets that we find, that man, God, there's a fine line where you can contradict yourself constantly. I apologize if I do. But Jupiter, scientists think that it was actually formed closer to the Sun and moved out. So I can't say really that the closer planets are usually rocky, because that's not true. We're finding out. Man, that's what I love about science in general. And God, we learn so much new things constantly. Like I said, I remember 2006. Jupiter only had like 36 moons. Now we find and the cool thing about Jupiter is it's so big. There's some moons that are retrograde, that spin the other direction, and so obviously those were probably caught later by Jupiter's gravity, like asteroids, comets flying by that got caught in the gravity, of Jupiter. And so that's why you would get them going retrograde, why the other moons, when it formed, are spinning the same way. Um, tidally, they're moving in the same direction as Jupiter. Um, and everyone's like, oh my God, Jupiter's the greatest planet because it shields us, but it also, it also attracts and throws in, it can up our chances of getting hit by asteroids as well. But man, honestly, really, I just, have you guys heard, have you guys heard this guy, I think he was a Japanese fellow, maybe Chinese. I'm not sure. I'll get into this though because it's a really interesting uh, information. This guy was doing a very detailed study paper on the asteroid that hit. Well, the one they think killed the dinosaurs. Um, and he was saying that where this asteroid hit, there is no there's no way that with as much debris that came up, there's no way that could have killed the dinosaurs. Now this is I'm reading this is a paper I was reading about a week ago, so I'm cloudy on it, and don't quote me on it but check it out. Look at Google it, because the place where it hit the density of the Earth where it hit, it was not one of the places that would have kicked up so much debris that it would have killed off the dinosaurs. Like I said, don't quote me on this. Is something I'll do a show on it if you would like. I would love to do that. But it's really interesting. Of course, conspiracy people jump on that, and they're like, the aliens put it there, and they're the ones that did it so they could, make life. And then why are the lizard people still here? This guy, really nice dude. I really do like him. He calls in. I don't know what star system he says he's from, but it's very interesting. I'll message him, tell him to call back in. Yeah, it's a very interesting conversation. We talk, I got his information, and yeah, he's from a different star system. Really, really cool. I'll have him come back on here and talk again because it's really interesting. But anyway, yeah, so that whole thing it's really cool. But anyway, so Jupiter, why it could be a great thing, a great shield for us. It's also a great attractor. I mean, it is the biggest planet. Jupiter is actually. Sorry, I just did this. That's why I was going to do a thing on Jupiter and then its moon, but I'm getting to it. But Jupiter is like the big ape of the solar system. It was actually, it was being formed to be a sun, actually, and some even speculate to say, some scientists think, because our sun, there's they again. It's always they. So I always change that, the ambiguous they, thems, you know what I'm saying? But scientists think that could possibly be the binary, the other star that was formed with our sun, but I don't think that would so much be it. But it was formed actually as a gas giant it's the closest thing to a star. It's right before it was, I guess it didn't get enough stuff to make it all the way to a star. Yeah, I guess. So yeah, sorry, I apologize. I keep talking about Jupiter. It's super awesome planet. I mean, it really is its own solar system in itself. So you ask, what are planets? Well, where did they come from? Well, why would some be rocky and some be gaseous? Well, what is our planet like? And this is a way to possibly, I hope, can answer some of these. I don't know. Like I said, it changes all the time, so new information is constantly popping up. That's what I love. It's like I won't get into it. sorry, I apologize. I start to ramble. So the birth of the sun first really is how the solar system usually will start. I wasn't there. I can't say for sure, but we have a good idea. Let's quickly review how our star came into being. 5 billion years ago, a giant cloud floated in one of our spiral arms of the Milky Way galaxy. This cloud, called a nebula by astronomers, was made up of dust and gas, mostly hydrogen and helium, with a small percentage of heavier atoms. These heavier atoms had been formed earlier in the history of the universe when other stars aged and died. This is happening all the time. There's actually different. Yeah, well, there's actually different um, places that where stars are constantly being born. It's really cool if you get to your telescope, if you have one. And where is it? It would be, what nebula is it? Maybe where you can see, obviously not see stars being born, but you can see where it kind of looks like a cloudy, well, kind of like how the Milky Way would be in the center, where it's just cloudy. It doesn't look like a bunch of little stars sitting there. It's so many that it's just sort of cloudy. It's super really cool. But anyway, sorry. This cloud nebula began to contract, collapsing in on itself. The atoms, once separated, began to jostle each other, generating heat. Atoms just running around, just cramming into each other. Can imagine how many atoms and how many things are just like completely colliding with each other to form that. I'm so sorry. It fascinates me. The atoms, once separated, began to jostle. In the rising heat, the atoms collided more frequently and more violently. Eventually, they reached a temperature at which the protons at the centers of the atoms began to fuse in a process called nuclear fusion. As they did, a tiny bit of matter transformed into a whole lot of energy, and a star was born. Boom! In this way, our sun came into being. The material in the nebula, not absorbed into the sun, swirled around it into a flat disk of dust and gas, held in orbit by the sun's gravity. Gravity is another, get into that one too, sorry. This disk is called an excretion disk. Material in the disk accumulated by further accretion from sticking together. Each planet began microscopic grains of dust in the accretion disk. The atoms and molecules began to stick together or accrete into large particles. By gentle collisions, some grains built up into balls and then into objects a mile in diameter called planetesimals. Do not think the other words. These objects were big enough to attract others by gravity rather than by chance. Yeah, in the way that the moons, the way that the systems were all, it's definitely not by chance. It's amazing. It blows my mind to think about how, and like the scale of it all. That's what blows my mind. If the collisions of the planetesimals occurred at high speeds, they could shatter the objects, but when impacts were gentle enough, the objects combined and grew. For some 10 to 100 million years, these protoplanets, orbited the sun, some in egg-shaped circuits that resulted in more frequent collisions. Another way to think about this is really, you know how you in if you have dogs especially, I guess you gotta, when you're cleaning up, your house, and you haven't got under your couch, and you're sweeping around, and you look under there, and you start to see like these balls of fur, and then they're starting to kind of congregate, and it's the same thing, obviously on a under the couch scale, but it's the same thing. There's little bits of dust and little bits of stuff in that little ball of like little fur, or like I said, especially if you have dogs, there's little grains of dust and then little thing, and you see these little balls start to ball up and congregate. Don't roll on that, Lincoln. Come here, Linky. You hi. I know. You say hi to everybody. Did you say hi? Lincoln's my little dog and aunt. Yes, she is. Hi, Dinky. You okay? You having a good morning? I love my doggy. Hi. You okay? Hi. You say hi to everybody. Ooh, your foot is really getting worse. Okay. You say hi. Did you want to say hi to everybody? I will. Okay. Um. Now, when worlds collided, combined, and evolved for a dramatic period of time, they grew. God, it was like I guess because I was there. Oh, it's well, what did they? It's like 4.5 billion years. Billion is a huge number. It's a million millions, and it's hard for me to formulate that whole thing. I mean, that means that 400 million years is crap to a million. I mean, to a billion. It's really crazy but when it was over, there remained 8 stable planets that had swept their orbits clean. A planet is defined as a body that orbits the sun, is massive enough for its own gravity to make it spherical, and cleaned its neighborhood of smaller objects. So its orbit around the sun, it cleaned up and absorbed all the dust and all the particles that were in its path. Uh, in 2007, researchers of the University of California, Davis determined that our solar system was fully formed at 4.568 billion years ago. So what's this? Yesterday? Well, really, in cosmic terms, it's a week. Sorry. They did this by determining the age of stony materials from the asteroid belt. The sun sent out energy and particles in a steady stream called stellar winds. These winds proved so strong that they blew off most of the gases, give or take, um, of the 4 planets closest to the sun, leaving them smaller, with only their rocky and metals intact. That's why you get the rocky and terrestrial, planets in the closest sun. They got all the hard materials, and see each star, obviously, what the materials made out of is what really initially are gonna be the basis of each solar system and core. Um, but you know, uh, as it well, yeah. I try not to do this where I contradict myself, but I constantly do it. I apologize. Um, now, the 4 outer planets were so far from the sun that its winds could not blow away their ice and gases, so they remained gaseous with only a small rocky core. Uh, they were made of more gas, namely hydrogen and helium, than the others to begin with, the sun's gravity having pulled closer the heavier materials in the original solar disk, hence the closer, the 4 Rockies. Mercury, Venus, Earth, and Mars that you guys didn't know about until today. Thank you. Just kidding. Between the inner and outer planets lies an area filled with millions of asteroids, small rocky, icy, and metallic bodies left over from the formation of the solar system. No planet formed in this area. Astronomers theorize that Jupiter's gravity influenced this region so much that no large planet could take shape. Jupiter is 11 times the size in diameter of Earth and more than twice as big as all the other planets combined. It is almost large enough to have become a star. Uh, it is. I mean, the mass of Jupiter. Yeah, all the planets combined. It's bigger than all the planets combined. It's really fascinating playing to do. It really is. And I will get to Jupiter, and I cannot wait. Stay tuned. It will be fun. I promise. Of the 4 rocky planets, Mercury is the smallest, about 1/5 the size of Earth. Earth and Venus are almost the same size, while Mars is about half their size. Astronomers speculate that a smaller object must have hit Mercury, vaporizing its crust and leaving only the larger than usual iron core. That's the ones that we saw. Lincoln, remember that? A million years ago? Conditions on Earth. When the rocky planets first formed, they were largely molten rock. Over hundreds of millions of years, they slowly cooled. Eventually, Mercury and Mars, because they are small, solidified and become rigid all the way to their centers. Only one Earth, and possibly on Venus, have conditions remained in an in-between state. Earth has stayed partially molten, its crust is solid rock, and its mantle is rigid in short-term time. But over geologic time, the mantle flows slowly, and the center of Earth consists of solid iron core rotating in hot liquid called magma, constantly changing. I think that some scientists think that if we were to fall off the face of the earth, no pun intended, that our stamp on time would be gone. I think within like a million years, you wouldn't even know that we existed. Just with the lava, the molten lava just constantly flowing, coming up, covering everything into, over and over. Uh, some scientists and big historians use the term Goldilocks conditions to describe conditions on Earth. This becomes from an Anglo-Saxon children's story, Goldilocks and the Three Bears. In the story, a young girl named Goldilocks wandered into the home of three bears, uh, who weren't there. I don't know why I put this, but this is the Goldilocks. This is how the Goldilocks theory came to be. Just in case you guys have never heard of it. She tries out their porch and chairs and their beds, finding some too hot, too cold, too hard, too soft, too large, too small, but one was just right. Likewise, Earth is not too hot or too cold, not too big or too little, not too near the sun or not too far away, but just right for life to flourish. Now, I think that contains, if Earth were bigger and the gravity was stronger, we would have been, made to form of what that was. But it's not, and it's how it came out. Now, Earth Moon, the rocky object nearest to us, is the moon. And where did it come from? Nobody knows. Aliens think people think that aliens made it and put it there. Other people, nobody really knows. Nobody absolutely actually does know. It's really crazy because the moon is a mystery in itself that, God, it's crazy because there's no solid foundation of how they think it got there. The moon's the moon orbits Earth, not the sun, so it's not a planet. The moon is about 1/4 the size of Earth. The origin of the moon remains mysterious, but since astronauts walked on the moon in 1969 and brought back rock and soil samples, we know more about it now than before. And now with Artemis, it's going to be super awesome going back to the moon and establishing bases. I mean, they want to put bases. They want to have a constant orbit so that more and more people can just go straight there, orbit, and be taken down to the moon. This is supposed to, I don't know if it's going to be true, but their idea is that, this is going to be where people can soon just be, not soon, but just going to the moon. Really cool. The standard argument today holds that a small contending planet about 1/10 the size of Earth must have collided with Earth about 4.45 billion years ago. Earth was still red hot beneath a possible thin new crust. Some of the material from the impact was absorbed into the liquefied Earth, but some material was thrown out into space, where it settled into orbit and condensed as the moon. As the first moon orbited much closer to Earth, it's still moving away at a rate of almost 2 inches, 4 centimeters per year. And that is the same, what is that called? There's Um, oh God, bless sheets, as in blankets and pillows. My mom told me, and I not to cuss them, so I don't. Um, I wish I could remember what that was. It was, God, I can't remember. I can't believe it. I feel, spin orbit residence. Yes, that was it. Can't believe I remembered. I did not look at my note. The moon significantly affects conditions on Earth. The impact that produced the moon's tilted Earth on its axis, this causes the Earth's seasonal variations in temperature since the side tilted toward the sun for one half of the year's journey around the sun receives more direct sunlight. Also, the moon's gravity causes the ocean's tides, reduces the Earth's wobble, which helps stabilize climate, and slows the spin of Earth. The Earth used to complete a rotation on its axis in 12 hours, but now it takes 24. Now, of course, anybody can go on about how the moon, you know, could say that I'm wrong because, well, it's pretty cool. Even Carl Sagan and all the greats, I mean, they don't think that it could have been by chance either that the moon, but that's just how it goes so far. Now, Pluto and beyond. Before 2006, students learned that our solar system had 9 planets, not 8. Haha. The one counted on the ninth was Pluto, orbits furthest from the sun. However, in 2006, the International Astronomical Union declared that Pluto does not count as a planet. I cried that day. I did. I just, man, growing up since I was a tiny kid, I mean, Pluto was like, yeah, I cannot believe they did that. But anyway, it is small. It's smaller than Earth's moon. Its orbits way out in a belt of asteroids beyond Neptune. Though Pluto periodically comes closer to the Sun than Neptune and does not have enough gravity to clear the neighborhood around its path, I thought, no, I guess that's why they did consider it a dwarf planet. Therefore, it was downgraded to a dwarf planet on a planetesimal. Astronomers feel confident that our solar system formed by excretion because now they are able to glimpse a similar process occurring in part of the Orion Nebula, which is a super cool. Man, I love the Orion Nebula. It's amazing. This planet forming area is on the near side of the giant cloud complex that embraces much of the constellation Orion, 1,500 light years from Earth. In 1993, astronomers have discovered several hundred stars there in the process of formation, most of them surrounded by rings of dust and excretion disks, just like the one they believe producing the solar planet. These clouds of dust and gas around new stars in the Orion Nebula may develop into planetary systems similar to our own. That is a really, really cool. You know, when you look at those pictures and you're like, God, how, yeah, that is that. I guess I guess in that they a lot of them describe that they draw a lot of that in, but I mean, you kind of have to, but it's really cool the way that they got that figured out. Now, and we get to know about that here in just a minute, so don't go anywhere. A wonderful word from everybody but me, because who doesn't want to know? Oh, weird. Wow, that's nuts. Wow. Oh, sorry, I'm reading something.
Money finds sneaky or forgotten subscriptions and makes canceling them as easy as clicking a button. On average, Rocket Money users save over $720 a year. Here's how it works. Just open the app. Go to the Reoccurring tab. And here, you can see all your reoccurring subscriptions. Tap on the subscription you want to cancel. Then tap Cancel Now. And you're done. Subscription canceled. No confusing websites, no auto-renew, no long hold times. Want to save up to $720 a year? Don't wait. Get Rocket Money right now.
Imagine you're leading a game of 20 questions, but halfway through you forget the thing that you chose. You have to keep answering yeses and nos and hope that you think of something that's consistent with all of your previous answers before the game is done. Well, it could be that this is what the entire universe is doing as it creates our reality. I hope it thinks of something good before we run out of questions. Scientists are fairly attached to the idea that the universe is real. We're fond of the realist viewpoint, that there's an objective reality out there that's entirely independent of our subjective experience of it. That seems innocent enough, and it has served physics awfully well. But take this viewpoint to the extreme, and we imagine the scientist as this perfectly detached observer of the world, capable of monitoring and modeling physical reality without ever disturbing it. But then came the 20th century and quantum mechanics. In quantum mechanics, not only does the act of measurement profoundly influence the thing being measured, but it seems we can't even assign physicality to the world between measurements. As Niels Bohr put it, no phenomenon is a phenomenon until it's an observed phenomenon. Bohr led the charge for this observer-dependent view, encapsulated in his Copenhagen interpretation of quantum mechanics, which insisted that the world only becomes meaningfully defined through the act of measurement. Others were desperate to maintain a physical and realist universe, including Albert Einstein. Now, we've talked about this debate between the founders of quantum theory before, and of the supposed resolutions, which I'll come back to. Today, I want to begin a discussion of a family of quantum interpretations which say that the universe exists not so much in the physical particles and the quantum fields, nor solely in the mind of the observer, but rather in the interaction of the two. To give a better sense of why we need to go to these crazy lengths to explain the universe, let's review some quantum weirdness. We'll start with the good old Schrödinger's cat thought experiment, devised by the ardent realist, Erwin Schrödinger, to highlight the absurdity of the Copenhagen viewpoints. We have a cat in a closed box that is either killed or not killed by a random quantum process. For a scientist running the experiment, the cat is in a twin state of being both alive and dead until the box is opened, a superposition of states. Or so quantum mechanics seems to suggest. This seems even more absurd when you add the so-called Wigner's friend extension, where a second scientist waits on the report from the first, rendering to them both the cat and the first scientist into a superposition of states. And doesn't the cat get to observe its own state? Or perhaps to the cat, the scientists are in a similar superposition? The heart of the problem is a simple question. In a world where observation plays a role in defining reality, how is it possible for separate observers to share a single consistent reality? Solutions to this seeming paradox span the spectrum. For example, the Hungarian physicists John von Neumann and Eugene Wigner doubled down on the observer-centric view, in which the act of observation in some way creates reality. Others found schemes by which a real physical universe could be interpreted in the behavior of the wave function, such as the de Broglie-Bohm pilot wave theory or objective collapse interpretations. Still others sought to explain the observer's influence as a sort of selection bias, For example, Hugh Everett's many worlds interpretation and the ideas of quantum decoherence. And then we have Richard Feynman's no interpretation of quantum mechanics, in which he suggested politely that his colleagues quit philosophizing and shut up and calculate. In the end, most physicists took that advice. They were eager to put the whole mess behind them and get on with the job of actually using quantum mechanics to invent the modern world. But a very few select physicists refused to let it go. One of those was John Archibald Wheeler, a prolific physicist whose students included Feynman, Everett, Jacob Bekenstein, and Kip Thorne, among others. Wheeler was never completely satisfied with any of the proposed quantum interpretations. Although he started out as a pure realist, he actually came to believe that the observer must be in some way fundamental. And yet, he couldn't accept what he saw as the solipsistic view of von Neumann and Wigner, in which the observer was in a sense the primary causal agent and center of their own reality. After decades of thought, Wheeler came to a view that is summarized in his expression, it from bit. In his words, every it, every particle, every field of force, even the space-time continuum itself, derives its function, its meaning, its very existence entirely from the apparatus elicited answers to yes or no questions, binary choices, bits. In other words, he came to believe that the universe is fundamentally informational. Wheeler felt that reality must have its primary existence not in the observer, nor in the subject of observation, but rather in the connection between the two. One of the thought experiments that led Wheeler to this view was his delayed choice experiment, which is an analogy to the double-slit experiment. Here's one example of this. Imagine a single photon hitting a beam splitter, a semi-reflective mirror that has a 50-50 chance of transmitting or reflecting the photon. If we add a pair of detectors, we see that each photon randomly arrives in detector 1 or detector 2, revealing whether it was transmitted or reflected by the beam splitter. But remember, I said that...
So sorry. I didn't really mean to let that. It sure is. Sorry, I didn't mean to. That was not. I had to go and run and do something. I'm so apologize. Deeply apologize. I'm so sorry to everybody for that. So, as we are moving and further into this, alright. So, my phone is up. Alright, yeah. And I need to, Podbean will not let me do my stuff more than 2 hours, so I sometimes run it a little bit over. But, in 1995, astronomers in Switzerland found for the first time a planet beyond our solar system orbiting an ordinary star. Such a planet is called an extrasolar planet, or an exoplanet. As of June 2012, more than 700 exoplanets have been discovered and confirmed. Most of them at giants closer in size to Jupiter, as larger planets have proved easier to deduct hundreds of light years away. Detect, not deduct, I apologize. Most are detected not by direct imaging, but indirectly by measuring the effects of their gravity on their parent star, or by observing how the light of the parent star dims as the planet passes in front of it. And I remember growing up, I remember when I first started hearing about exoplanets. I was like, no way. They found there's other planets. And when I started learning more about how, man, God, growing up was so just with what is the technology we have today in comparison to what we had when I was growing up. If I were in my, I'm 46, so I'm not, I'm not incredibly, man, there's a lot of, oh, you got Booger. Good boy. Where did the ball go? I hope we didn't lose the ball. But I always come back to like, God, when I was growing up, when I was a kid, we walked backwards in the snow. Yeah, I mean, that's exactly what I think. Basically, I'm starting to, sound like. Yeah. Like my grandfather did. Yeah, I know. How horrible is that? I apologize. I know. Man, when I first started doing this podcast, I was really kind of doing a timestamp so that I could, and it was. They started finding all these exoplanets, and then when I found out that our solar system was not just sitting still, that it was flying through it, I was blown away. And I was like, dude, I want to start having a timestamp on when these things are occurring. So that's when I started doing my podcast thing so that I could have a recorded timeline of when things are being, made. And I only really just started doing, so my timeline doesn't go back very far, but I'm trying. It's super fun, and I love doing these. I love doing these. I guess you call them shows or whatever they are. Podcasting. I love doing them. They're super fun. I probably suck at it. I'm sure that, yeah. I'm sure my voice is annoying. But I have so much fun doing it. I hope that it's entertaining for you guys. That's what I always say. And let me know if there's anything I can do to make it, funner, more enjoyable for your listening pleasures. Now, um, in 2009, the National Aeronautics Space Administration sent a telescope into orbit around the Sun to hunt for habitable exoplanets in the region near the constellation Cygnus and Lyra. This telescope, actually a photometer, the centerpiece of what's known as the Kepler mission, will monitor 100,000 stars a few hundred to a few thousand light years away, or 1 light year equals 6 trillion miles. Yeah, I mean, basically, a light year is 100, you go 186,000, give or take, 186,000 miles per second per one of our years, or 6 trillion miles for the whole year. The mission will last 3.5 to 6 years. In the first 2 years, it has found 17 planets with conditions thought to allow for the development of life. I think they figure, what is it, 5,000? One of every 5 planets are Earth-like, I guess. That's what I mean. That's give or take. But in summary, planets are bodies orbiting a star. Planets form from particles in a disk of gas and dust, colliding and sticking together as they orbit the star. The planets nearest the star tend to be rockier because the star's wind blows away their gases, and because they are made of heavier materials, as we were saying, attracted by the star's gravity. In the Sun system, Earth is one of the 4 rocky planets, but a unique one, with rigid and molten layers. So, I hope you guys had fun. We get back to Earth, and I'm kind of running out of time. But please leave comments. Please, if you guys want to hear anything you would like to hear, let me know. If anything you want me to do any kind of show on or anything like that. I love doing these. I have so much fun doing it. Please let me know. You can even tell me how crappy I'm doing, and I will, learn from that. But I thank all of you for listening. Like I said, if you have any questions ever, let me know. Clayton, thank you for joining. Pastor, what's up? Thank you for joining. Mr. A, Ronald, all of you guys, I appreciate it. Everybody at the Pepsi Planet. Man, what's up, guys? I appreciate it. You guys are super awesome. Everybody. Thank you a million. You guys have a wonderful day. Don't miss. Okay, so today, I went over the solar system. Sorry, I wasn't even trying to jump out. So today, kind of did the solar system. Clayton, you brought up a very good point. I actually wish I would have gone into the Milky Way first, or I mean our galaxy. I did one on galaxies about a month, or a couple of weeks ago, maybe a month ago, on the different kinds of galaxies, and that was super fun. Like I said, I love doing all these. Usually, and I love keeping everybody up on the space exploration. And if you go to my website on here, I have if you go on, I have a page on my website where you click, and it has all the celestial things that you can look at with your telescope or binoculars for the current month that we are in. I have not go on there and check out my crowdfunding page. Get on there and check out my fan base, to be a fan base, because through my fan base, you can hear Monday through Friday. I do, my live shows, and I'm going to start doing Tuesdays and Thursdays for my pre-recorded stuff, and that's going to be super awesome. I'm getting help, so Kevin, I hope you're ready, brother, because I'm gonna need it. My day job really takes a lot of my time, but but I love doing this, so I continue doing it. My day job from 5 in the morning to 6 at night really takes up a lot of my time, but that's fine because I love doing this. So anyway, I think my fan base I think actually from the app it's easier to do this, but I'm not sure. But man, please leave comments, please hit like, and please share, and just throw my name out there, my ToNoAvaiL Astronomy podcast, or the Infinite Cosmos. They're both kind of the same. Like, when I start to get into the conspiracy stuff, I kind of leave it with the ToNoAvaiL, and the Infinite Cosmos is more of like astronomy. I don't think that aliens are really astronomy so much as, I know it has to do with space and all that, but you know what I'm saying. So anyway, go to my website on Podbean, check that out, and go to my crowdfunding page, check that out. If you throw $1 or $3. If you just won the lottery, I don't know. I'm only asking for like $1 million. It's not that much. I'm just kidding. If you can, the support's awesome. If you can't, but go on there, become a Patreon, and become a fan on my fan base page, because it's going to be super cool. And everybody, I appreciate you guys all for listening. You guys are all super cool. I really do appreciate it, and you guys are all super awesome. You guys have a wonderful day. Be safe out there, and I will talk to you tomorrow. I think, and I'm not sure, but yeah. Yes, I'm sorry. Tomorrow, I will be going over, but what was I going to do? I think I'm going to start going over the planet, sort of, and then we're going to get into moons. Jupiter, God, I can't wait to do Jupiter and all of its moons. You guys, it's really, really cool. So, don't miss that. Check it out. I know. Calm down. I know. Don't make me blush. I see you back in the corner.